let's finish off lesson 1, taking more derivatives of exponential functions with base e. And these examples are going to have quotient law questions, and then this is going to be a combination of product law and chain rule in here. And then we'll do an implicit question, so a variety. Okay, so remember for the chain rule, if you're taking the derivative of you have a function in the numerator and a different function in the denominator. So y prime is equal to, it was low d high minus high d low, draw the line, and square below. So let's look at this first one. Y is equal to e to the 3x over x cubed. So differentiating y prime, actually maybe I'll write dy dx since that's what they're asking me to find. Dy dx is equal to low d high. Derivative of e to the 3x is e to the 3x. Derivative of 3x is 3. So low d high minus high, and then d low. Derivative of x cubed is 3x squared. Draw the line and square below. I've got x cubed is my function, and I'm going to square that. Dy dx is equal to, I will have 3x cubed e to the 3x minus 3x squared e to the 3x. Power to a power, you're going to multiply, and you're going to get x to the 6. In my numerator, I could factor out a 3. I could factor out an x squared and an e to the 3x. So dy dx is equal to, factor out a 3, let's factor out an x squared and an e to the 3x. And what I have remaining is x minus 1 all over x to the 6. And then how this could clean up, if I've got 2 x's on top and 6 on the bottom in the denominator, I would be left with a denominator of x to the 4. So what that would leave me with is dy dx is equal to 3e to the 3x, x minus 1, all over x to the 4. Okay, let's look at this question. This is going to start as a product law question. So this is going to start as uv prime plus vu prime. So u, now v prime, taking the derivative, it's going to be a chain rule question. So 4 2x minus 3 to the power of 3, and then the derivative of my inner function is 2. So u v prime plus v, and then u prime. The derivative of e to the 5x is e to the 5x. The derivative of 5x is 5. Y prime is equal to 4 times 2 is 8, e to the 5x, and then I've got 2x minus 3 to the power of 3. And then I have plus 5 e to the 5x, and then 2x minus 3 to the power of 4. Okay, I could factor out is, let's see, each term has an e to the 5x, so I could take out an e to the 5x. Then I could take out this binomial, 2x minus 3. I'm going to take out to the power of 3, so take out always the lowest exponent. So y prime is equal to e to the 5x, and then I'll factor out 2x minus 3 to the 3. And what that would leave me is, I would have an 8 here plus 5, and then one of those brackets would remain. Just to solve this, this would be 8 plus 10x minus 15. What would that be? That's going to be 10x minus 7. So that would give me y is equal to e to the 5x, 2x minus 3 cubed, and then 10x minus 7 would be the derivative. All right, let's do, I think there's 2 more questions. We'll do this one, which is actually going to be it's a product law, but it is going to be quite quick. And then we'll do this one, which I believe is a homework question, but it's going to involve implicit differentiation. Okay, so let's look at differentiating 2x times e to the x. So u v prime, derivative of e to the x is e to the x, derivative of x is 1. So uv prime plus v, and then u prime, derivative of 2x is 2. From here, I could factor out a 2 e to the x, and I will get x plus 1. Okay, let's look at this last question, which again I believe is question number 6 from your homework. So find y prime if. So what we're going to be doing, I don't want to just subtract 2x and bring it to the left and then differentiate y, because I also have y on this in this term, which means this is going to be an implicit question. Okay, so what we are going to do is we are going to differentiate both sides of this equation with respect to x. So the derivative of e to the xy is e to the xy. And then I need to multiply this by the derivative of x times y. Now, x times y, this is going to be a UV question. So again, differentiating e to the xy, the derivative of e to the xy is e to the xy, and then I need to multiply it by the derivative of xy. So the derivative of xy is going to be u v prime. The derivative of y is 1, and then I just took the derivative of y, so y prime. So u v prime plus v u prime. The derivative of x is 1. Okay, so that is differentiating e to the power of xy is equal to the derivative of 2x is 2, and then again, I could write dx over dx, but that just cancels, plus the derivative of y is 1, and then I just took the derivative of y, so y prime. Okay, what we want to do is we want to eventually get our y primes on one side of the equation, but let's get rid of this bracket by distributing in this e to the xy. So I've got e to the xy times xy prime plus e to the xy times y. Let me fix that. E to the xy times y. So I just distributed this inside, and that is equal to 2 plus y prime. Okay, let's bring all of our y prime terms to the left-hand side. And this does not have a y prime, so let's bring this term to the right-hand side. So if I do that, I will be left with e to the power of xy times x y prime. I'm going to bring this to the left is equal to, I have a 2 here, and I'm going to bring this term to the right-hand side. From here, I want to isolate y prime. Sorry, when I bring this over, it's going to be negative y prime. I want to isolate y prime, so I'm going to factor out y prime from these two terms. And I will get e to the xy times x minus 1 is equal to 2e to the xy times y. And then I want to get y prime by itself by dividing both sides of the equation by this factor here. And I will get y prime is equal to 2e to the xy times y over e to the xy times x minus 1. And that is your derivative. Okay, for homework, here's everything from 8.1 and 8.2. Now, really important, again, that you do this homework before you go on to the next lesson. 8 and 10, if we look at what 8 and 10 are, 8 and 10 are going to have to do with graphing questions. So you're going all the way back to the unit on graphing, where you're finding the first derivative, which is going to find max, local mins. So when you do 8 and 10, you might want to have your these work solutions opened. And maybe if I have time, I'll make a video of these two questions being solved. They're important because they're tying in a previous unit, which was our graphing unit.